Thank you, Liska, and thank you everybody for joining. We have some people in the webinar that have visited us before, either physically or in Amsterdam or remotely in the webinar, and some people are new. For those who are new, let me take this opportunity to quickly introduce myself and Exonic. So my name is Frans van Buul. My official role at Exonic is, as my mug says, not the sales guy, meaning that I am responsible for telling the world about our products and how great they are. But I'm not the average sales guy. I'm actually a Java developer for my background. I've also spent some time in the security world before venturing into Java, and this will actually play a big role in what we're about to see, because it's all about encryption and other security stuff. So Exonic is a very new company. We were founded in July of this year, so about half a year now. We focus all on Axon framework, based in Amsterdam, currently 11 people and growing rapidly. And we basically have two lines of business. The first thing is to deliver support and training, all kinds of services built on our Axon framework knowledge. And the other thing is a couple of commercial software products that can be used in conjunction with the open source Axon framework, which is and will remain open source by itself. This is our product roadmap. Our main roadmap is the stuff in green. So there's the event store, a high performance alternative to databases for storing events. We've done a webinar about that 3 weeks ago. And after that, we'll continue on that track by building the messaging platform. We've started our development of that thing now, and we'll continue with monitoring and analytics. And kind of as a side track, we've built this GDPR module, which is the topic of today's webinar. And the reason we built it is that we noticed there was a big demand, a specific issue with our customer base, and there was a strict deadline to solving this issue. So we kind of took this sidetrack to solve this. But we'll talk a lot more about this in detail, of course. Today's agenda has two main parts. So the first part is more about describing what this problem really is about. So what is GDPR, what is event sourcing, and where are some tensions between those two things. Now we have quite a mixed crowd today. I know many of you are IT people who may be relatively new to GDPR. There are also some people who are from the IT audit and compliance world that may be a little bit more newer to some of the software architecture concepts that we will be talking about. So what we will do is quickly introduce both, so discuss GDPR, discuss event sourcing, and then start combining those two things. And then the second major part will be about the specific Exonic GDPR module that we've built. What are the concepts behind it? How did we design it? We will actually do some live coding as well, so you can see how this will be used. And we'll discuss in detail how the encryption included in this module actually works. So first start with GDPR and event sourcing, and arbitrarily I'll pick GDPR as my first topic. So what is this? Basically it's EU legislation. In full, this stands for General Data Protection Regulation, and it also has an official number in case you want to look it up. It covers the protection of personal data, so it's not about data of corporations or anything like that. It's about the personal stuff. This domain is also referred to as privacy. It replaces a previous directive called the Data Protection Directive that was established in 1995. And this will become applicable next year on the 25th of May. Legally speaking, it is already law. It's just that this law has a provision that it has a 2-year transitional period, which also means that you really have to be ready on 25th of May. There is no excuse like there was no transitional period, because actually there was one. Importantly, this thing is a regulation as opposed to a directive. That may just seem like a different word for non-legal people, but there is an important difference. A directive is basically something that has to be implemented into national law by the EU member states. So for instance, in my country, we had the Wetbescherming Persoonsgegevens. In the UK, there was the Data Protection Act implementing this prior Data Protection Directive. The GDPR is immediately a law in and by itself, so it's stronger in that sense. If we look at what's covered by the GDPR, in essence, it's about the collection and the processing and the use of personal data by organizations, so capturing that entire life cycle. And within that life cycle, it sets some boundaries. What can organizations do? What can they not do? It gives them some obligations, for instance, the obligation to protect personal data appropriately. It describes certain rights of data subjects, like the right to know what kind of data is being captured about yourself. And it describes some enforcement mechanisms and sanctions that may hit organizations that are not compliant with this law. Now, of course, we already had some privacy law. So a very basic question is, what will change? Now, there's a lot of fuss going on about GDPR, many articles and news items, but I think at the heart of the matter is the fact that many basic privacy principles, in fact, will not change. Just to name a couple of examples, we have a very important privacy principle saying that if you process personal data, there always has to be some kind of legal ground. You cannot process that just because you want to. There is purpose limitation. If you gather someone's personal data for a particular purpose, you cannot repurpose that and, for instance, sell that if you haven't gotten permission to do that before. There's a requirement of adequate protection. There is a recognition of special categories of data. A phone number or an address is one thing, but information about your medical status or your political affiliation may be a lot more sensitive and requires different handling. There are a couple of rights that were already there that are still there, like the right to access data, the right to have data corrected if it's wrongly registered. And there was an important principle which was already in place and which is still in place, and that's that this legislation is largely technology independent. Legislation doesn't evolve as quickly as, say, Java frameworks, so it's important that the law is not too specific on specific technologies. So that's all stuff that doesn't really change at all. Of course, that begs the question, what will actually change then? Well, there are also a couple of things. First of all, and that's probably the reason why you hear so much about this, is that there will be uniform and very high potential fines. The reason that they're uniform is that this GDPR is a law in and by itself. Under the previous Data Protection Directive, it was up to the member states of the EU to design their own laws, and the fines included in those laws, so they were different per country. Under GDPR, that's no longer the case. The maximum fine is established in the GDPR, and it's the larger of 20 million euros or 4% of global turnover, which may of course be a lot more than 20 million. Of course, that's a maximum. It's up to the regulators in the individual countries to establish actual fines on actual transgressions. The scope is broader in a number of dimensions. It's broader in the territorial range. So it used to be the case that if you were totally outside of the EU and didn't have any entity established in the EU and you were doing things like selling stuff to EU citizens, you would be outside of the scope of the Data Protection Directive. That's no longer the case under GDPR. That those kind of activities will put you in scope of the GDPR. A couple of other scope broadenings. So effectively more organizations will be affected by EU privacy law than was the case under the prior regulations. A thing you may have heard about is mandatory breach notification. So if you know that personal data has been stolen from you, you need to report that, and it will probably end up in the media if it's an interesting case. There are some enhanced governance requirements. Depends a little bit on how big your organization is, but many organizations will have to assign a dedicated data protection officer, the DPO. There are things about doing privacy by design and some other governance requirements. And then the area of data subject rights, which was already there, is now strengthened. So the access requirements, so giving people the right to know what kind of data is being stored about themselves, was already there. But a new thing, for instance, is that it's now also guaranteed to be free. Under the Data Protection Directive, organizations could charge some money for the service of delivering you the information they stored about you. Under the GDPR, that's illegal. The service has to be free. There's a data portability requirement, so you need to export the data in a machine-readable format so people can take that data to a different processor. And importantly, and I've marked that in pink because that's the thing most important to the remainder of our discussion, is the right to erasure. Under the Data Protection Directive, people had some right of erasure, but mainly if there was any kind of illegal processing going on, but not a more generic right. There have been some lawsuits prior to the establishment of GDPR where there was a legal precedent describing a more encompassing right to erasure. And now under the GDPR, that has actually become part of the law. Specifically, it's Article 17, the right to erasure, also called the right to be forgotten, which basically says that the data subject shall have the right to obtain erasure, and in that case, the data controller has the obligation to actually do that. And then the remainder of the law, not quoted here, describes a number of specific grounds under which the data subject can claim that right. One ground, for instance, is withdrawal of the consent, assuming that the data processing was originally based on consent. And then the law also describes a number of exclusions, like conditions under which the data controller is not mandated to do this. And it's also totally reasonable. It's not an absolute right. For instance, examine assume that this would be an absolute right, and I could go to a bank, get a loan, and then say to the bank, please erase all information you have about me and not pay back the loan. Of course, that's not allowed. This is a conditional right rather than an absolute right. That's enough about GDPR for our present discussions. Let's take it to the different area of this discussion, event sourcing, and forget about GDPR for a while, and we'll bring them together after that. Event sourcing is essentially a kind of event-driven architecture. It's a specific thing within that general domain. Event-driven architecture is just software architecture based around the idea of processing events. It's a big trend. Just as one illustration of that, I've copied here a Gartner overview of the most important strategic trends for 2018, event-driven architecture being one of them. And it's quite clear why that is the case. Event-driven architectures really fit very well with microservices, with continuously changing systems, with systems that are not always on, with mobile. It's really a good answer to many of today's software architecture challenges. Event sourcing is a specific type of event-driven architecture, which focuses on the persistence aspect. So persistence being, in general, the mechanism that you use to store data into something like a database. Now, to understand what event sourcing is, first of all, we should look at how this is approached traditionally. So traditionally speaking, persistence is implemented by storing the current state of any object into a database. And then you establish CRUD operations, so create, read, update, delete. You modify that object as its life cycle progresses. With event sourcing, you do something totally different. You don't store the current state, but instead you say that all state change has to take place through explicit events. There's no state change without an accompanying event. These events are by their nature distributed, so other components can react to them, but are also persisted to an event store. And if you need to access current state, so retrieve it from the database, you cannot access that directly, but instead you replay the events that have led to this current state. Now, in this setup, events by their nature are immutable because they describe something of the past. They're also undeletable. They have happened. Of course, you can distinguish between conceptual immutability versus actual technical immutability. They may technically be in a database record that would allow you to delete them, but in this concept of event sourcing, they should be immutable and undeletable. Just to illustrate an example, shopping carts, orders, very well-known example. In this case, customer France has ordered a pizza and a soda from some pizza delivery company. In traditional persistence, this would just be the thing that's the actual order and also the model in the database. With event sourcing, it might look a little bit different. When creating this order, we created an order for customer France, and then pizza was added to the order, and then maybe ice cream was added to the order, and soda. And then the ice cream was removed from the order before it was confirmed. So this actually leads to the same state as the traditional picture on the left. So this actually includes quite a lot of complexity, and always if you use complexity in an IT system, you need to justify it. Why would you do that? There are actually many reasons, and broadly they fall into two categories. Business reasons and technical reasons, the business reasons being far more important in this case. the business reasons are in two groups. So one is all things related to auditing and compliance, transparency, basically stuff that has to do with the value of having the ability to retrieve what happened in any particular case in full detail, should that ever be necessary. And then the second group is more like data mining, analytics, machine learning, all kinds of things that don't really have to do with individual records, but with the data set as a whole, which focus on the fact that data from the past represents value. You can learn from that, so you shouldn't throw that away. You should keep that and make that value manifest for your business. And what we saw in the example is actually a very clear case where the second group would be relevant. You saw that I put that ice cream in my basket, but actually didn't order that because I removed it prior to confirming the order, which makes it totally irrelevant from an order fulfillment point of view, because there's no ice cream to be delivered. From a marketing point of view, it's highly interesting that I was on the brink of buying ice cream, but then decided not to. If I was a salesperson at this company, I would like to know why I didn't actually buy that ice cream and what we could do different to make sure that next time I will actually buy that ice cream. Maybe we should make it a little bit cheaper, maybe we should offer different flavors, can be all kinds of stuff. But having this knowledge is immensely valuable. So there are very strong reasons why you would choose event sourcing, and that's why many organizations actually do, and the number is growing every day. So now we've looked at those two components of our discussion, so to say. We've looked at GDPR, we've looked at event sourcing. Now let's try to combine them. First thing that you should note is that generally they are a very good match. GDPR demands a very high level of transparency. For instance, if you have obtained consent from someone to start sending all kinds of commercial emails, you need to be able to actually reproduce what happens when you recorded that consent, and there are many other scenarios like that. And event sourcing, making very explicit and storing explicitly all these events, is a good match with that. It gives you that audit trail that you need for compliance purposes. And then there is a challenge. So GDPR, as we have seen, has this right to erasure, Article 17. So erasure is sometimes a mandatory thing, and event sourcing says events are immutable and undeletable, and those two things seem to be at odds. So let's have a look at some ideas that we see in the market to combine those two things. So one idea is to delete events anyhow. So as we've seen, events are conceptually undeletable. Technically, you may choose to delete them because they're just records in the database. But there are some problems with that. So first of all, you may have consistency problems. The event source system may see that events are missing and will not be able to reconstitute all aggregates correctly after that. Also, from a business point of view, you're losing more data than you actually need. One event, like a particular order in a web shop, may contain personal data, like my name and address, stuff that you have to delete under Article 17. But there also may be a lot of non-personal data, like the simple fact that this order took place, which is something that you might want to remember for those analytics purposes. And if you delete an entire event, you lose more than you would actually want to lose from a business perspective. Another idea would be to modify events, overwriting individual field values. Works a little bit better probably than deleting entire events, but it's difficult to implement consistently. You would have to deserialize events from your database and then examine individual fields, overwrite them with some data, write that event again. Presumably you would have to implement that by scanning your entire event store, which is expensive to do computationally, especially if you have large numbers of events. And perhaps most importantly from a business perspective, that this kind of diminishes the value and the reliability of the event store in the audit role, because it's no longer without discussion that the event store represents what actually happened, because it's a common practice now to modify those events. So from that perspective, it's really something quite undesirable. Then another set of solutions that I've seen, especially on Twitter, is reinterpretations of the law. And I've seen two major flavors of that idea. So one idea would be to say, well, the law says I need to delete data, but I need to delete that operationally. So that's from read models if I do CQRS, but from backups and event stores, that's kind of like outside the scope. And another version of that argument is saying, well, there is this exclusion in the GDPR for data needed for legal claims, which by itself is true. And I intend to use my events to support those legal claims, so therefore my event store is excluded. Well, honestly, we can be very quick to respond to those things. So to the first one, just no, there's just nothing in the law that establishes that kind of exception or that notion of operational storage versus non-operational storage. And to the second thing, also just no. There is a legitimate exclusion for data needed for legal claims, but that's for specific data that for really current legal processes going on, not for any legal claim that may occur in the future. More generally, you could say that this violates the minimization principle. So within the privacy law, it assumes that you should not use data more broadly or keep data longer or keep more data than is necessary to do what you need to do. And just saying, well, all of my event store is needed for legal claims is a clear violation of that. Then finally, we've seen the idea come up of having separate contexts. So you could say, well, I split all my data into a part that has non-personal data and a part that has personal data. And then the non-personal data will be in an event-sourced context, and the personal data will be in a non-event sourced context. And then I kind of bring those two things together in read model projections whenever I need to produce data for my users. This adds lots of complexity in general, but in particular, it adds complexity of keeping this mapping in place. If you need to do this in an existing application, it's a huge refactoring. Makes your domain very unnatural in many situations, not all. And you will lose all the history and the other event sourcing benefits that you would otherwise have for the personal data bit, which may be a big thing. So it's not an ideal situation either. Summary, if you want to combine GDPR and event sourcing, then you do have an issue with mandatory erasure, and all those existing ideas have major downsides. And this led us to start developing this Exonic GDPR module. Basic idea behind the model is cryptographic erasure. So you store all the data in an encrypted form, and then to delete the data, what you do is you throw away the key. And because the key is no longer there, there's no way to access that data anymore. And it's an idea also called crypto erase or crypto shredding or digital shredding. Importantly, this is not our idea. We've seen this idea before. It's very common actually as a data sanitization strategy. So what do you do with media like hard disks or USB disks that still contain data and you need to get rid of them? Actually, this crypto erasure function is built into modern hard drives, like self-encrypting drives, and also into more enterprise-grade storage arrays that carry hundreds of hard disks at the same time. And because of this, it's also covered by a couple of security standards that actually endorse the usage of cryptographic erasure to seriously get rid of data. So it's not a new idea. The idea behind this GDPR module is to implement crypto erasure not on this media level, but on the application level for Java under a couple of conditions. It must be very easily usable, so no changes to this logic. Of course, also integration with Axon. Should be generally usable with any Axon version or without Axon. And it should be totally independent of mechanisms that you choose for serialization, like Jackson or Xstream, or your event store, which may be relational database or Mongo or the Exonic event store. We wanted fine-grained control, so decide exactly what you want encrypted, and very high level of security, because you need it for this purpose. You rely on the security basically being effective forever. Overview of the API. At the core of this API is a class called field encryptor. It has two methods, encrypt and decrypt. So they operate on an object, they are void, they don't require a key or anything. They examine annotations on that object. Based on annotations, we'll look for a key, then perform the encryption operations on the field of the object. That's the field encryptor class. This field encryptor class uses an interface called crypto-engine, and this contains the core cryptographic capabilities of key management, getting or creating the keys, or getting the keys if you have a read operation, and it also creates a Java cipher object, which is a representation of the actual crypto algorithm given a key. And this thing is also the carrier of the delete key operation. This is where you can delete a key and thereby delete the contents of fields. We offer various implementations of this interface. There is an in-memory implementation for unit tests, a JPA-backed application if you want to store your keys in a database. For the highest security situations, we also have the option of storing all keys and performing all encryption in a hardware security module supporting the PKCS 11 interface. Then on the other side, we have a class called Field Encrypting Serializer, which first performs field encryption and then serialization. It implements the serializer interface from Axon Framework and uses another serializer implementation as its delegate. The idea here is that it enables seamless Axon Framework integration. So if you register this particular serializer in your application, the field encryptor will be called upon automatically, and you will never have to do that explicitly in your code. Just to make it a little bit more concrete, let's look at it live. What I've set up here is a very simple event called a new customer registered event. It carries a customer ID, a customer name, and then a couple of addresses. The example is not supposed to be realistic in terms of how it's modeled. It's just to be recognizable and to have some of the features that enable me to showcase some of the features in the GDPR module. It's a simple test program. It creates one of those events, puts some data in that, and then prints it to standard out. So let's run this. And there we go. So it prints out everything in the clear, my name, Frans van Buul, and two addresses, a home address and a work address as expected. Now, if we want to encrypt one of those fields in order to make it deletable, I have to put some annotations on this thing. For instance, the name field, I could annotate that with personal data. That's the basic instruction to the GDPR module to encrypt that. But of course, it still needs to know how to establish a key to do the encryption. In this case, the key should be derived from this field, the customer ID field, and I tell that to the GDPR module by marking it with data subject ID. Going back to the main program, of course, the annotations aren't picked up automatically. So what I should do instead is instantiate one of those crypto engines. I will choose the in-memory one just to make it fast. And then I'll set up a field encryptor. I will give the crypto engine to the field encryptor, and then I can call field encryptor.encrypt my events. If I run it now, you would see that name has been totally garbled. That's now an encrypted field. If I decrypt after the encryption, of course, what you will see is that it's now in the clear again. It has my name again. But if I delete the key between those two steps by invoking the crypto engine method with the ID of the customer, what we will see is now the name is empty. Now it just defaults to an empty name. It could actually change that into an explicit string, or could even do things like showing a partial value of the name, but this is the basic principle. To illustrate a little bit more functionality, I also included this address type. What I can do is go into the address and then say I want to make the street part personal data as well. But then I would also have to tell the module that it has to look into this map, and in particular into the value side of this map and not the key side. And there's another annotation for that called depersonal data, and I'll give it a scope of value. And if I run the program again now, what you would see is that the street is now empty as well. House number is still there. House number is a bit of a different case. If we want to make that obscure as well, we have the problem that an encrypted version of that house number is by itself a set of bytes that we cannot encode into an int by itself. So what we would need to do is serialize that and have an additional helper field that can help us store that. So we call that field, for instance, house number encrypted, and then put an annotation here called serialized personal data. And that's an instruction to the GDPR module to serialize first, then perform encryption, and then store it in a helper field by default called encrypted, but you can call that anything you like, of course. And if we use this, then our house number will be gone as well. So using these three annotations, personal data, depersonal data, and serialized personal data, it actually allows us to encrypt any and all field in a Java application. Going back to the presentation, there are some more advanced features that we haven't shown, like using multiple keys per object if you want to have the ability to delete some fields but not other fields. We can do very customized replacement behavior, including things like keeping fields partially clear, like maybe the last 4 digits of a credit card number, or say, well, if I delete a date, like a date of birth, I want to delete the month and the day but still keep the year. All that kind of stuff is possible as well. Now, looking into this, how does this actually work? And conceptually speaking, it's very simple. You take the clear text value, you take a key, you run that through some encryption algorithm, and you end up with an encrypted value, and you store that again. Looking at it a little bit more deeply, there are some issues to think about. Like, first of all, what about long-term security? We know that computers ever get faster, so making attacks that are infeasible today may be feasible in 2 years. And in particularly, we may see quantum computing arrive, and that will make some algorithms fundamentally faster, and current encryption algorithms will be totally insecure, like RSA or elliptic curve algorithms. So we respond to this by, first of all, choosing a very standard, well-researched algorithm. So that's AES, it's the same algorithm that's used to encrypt top secret military information. It's the most secure thing that we have. It's a symmetric algorithm. It will not suffer from the same kind of weaknesses as the other ones as computer power grows. And we use it as a key length that has been researched to withstand even those quantum algorithm attacks. And the link there has some more information on it. But the essence of it is that if you use AES at a lowest key size of 128 bits, it's probably insecure against quantum computers. If you use 256 bits, it's probably secure. So that's what we use and recommend. Another thing is about semantic security. That has to do with the challenge that if you have the same field values and you encrypt them with the same key, you may end up with the same encrypted value. And then even if you lose the clear text or lose the key, you still have this information about sameness surviving. So in this case, even if you cannot read the clear text anymore, by just looking at the crypto text on the right, you may see that I had same dinner 4 times in 1 week, which is by itself a piece of information. So you don't really want this. So what we do instead is use AES in so-called CBC mode, where you have blocks of encryption being tied to one another and being initialized by a value called the IV, the initialization vector. And this initialization vector is randomly selected for each encrypted value all the times. And we actually store that into the field so that all fields are actually different, even if they are the same clear text. There's a detection thing you need to deal with. So if the module reads a value, it needs to distinguish between cases of clear text, encrypted text with an expected key, or encrypted text with a different key, which can happen if the key was created first for a particular ID, and then it was deleted and then recreated. Then there would be a key for that ID, but it would be the wrong one for the old data. And we don't have any metadata available or fields available to keep track of that thing. So we have to include information like this into the encrypted value. And the way we do it is by including 2 digests into every encrypted field. One is a digest of the IV and the encrypted data, and the other thing is an encrypted version of that same digest. So that allows us to reliably make the distinction between these 3 situations. So if we go into this picture again, this kind of high-level conceptual picture technically looks a lot more like this. I will not go into every arrow, but the important thing, and the reason why I'm showing it, is that we have very clearly documented all of this stuff. We have it's public, which gives you 2 major benefits. One thing is that there is no vendor lock-in if you use this mechanism. You could always implement this encryption process on your own and still have access to your data, even if you don't have our software. And the other thing is that it allows you to verify what's going on and to be certain that we're not just scrambling some stuff, but there is actually the strongest grade of encryption being in effect in this thing. So this is a very technical picture. If we zoom out again a little bit, so where does this capability that this module offers, this cryptographic erasure, where does this fit into an overall strategy to dealing with GDPR and mandatory erasure? Well, of course, it's part of your overall strategy. If a request for deletion under Article 17 comes in, there's a couple of things you should do. You should check whether it's valid, of course, and if so, a number of other processes should take place. There's the thing of deleting data from the event store. That's very hard to do if your event store is actually immutable, and this is where the Exonic GDPR module gives you a very easy to implement a solution. But then the other stuff you need to do is delete it from your read models first. You may choose to use the GDPR module for that as well, but we don't expect that to be the major use case. Probably we'll just do a database delete for those. And then you will need to inform third parties if you have shared that data with them. And you're also mandated by another article in the GDPR to inform the data subject about the fact that you have processed their request for deletion. So if you're using event sourcing, probably the way you want to do this is by raising some kind of deletion event and then reacting to that in various parts of your application. Finally, about the delivery and licensing of this module. We deliver it as a jar file with associated POM files, so you can include it in your Java and Maven projects. It has an extensive reference guide, and we deliver it in 3 different versions. So there's a version for Axon 3, Axon 2, and Axon Core. They are totally the same in terms of their cryptographic capabilities. The difference is in the way they use the serializer, because the serializer is different between those 3 models. From a licensing perspective, this is a commercial license, so it's not part of the open source. The key metric here is the number of running instances, where we only care about production instances, so you're totally allowed to run this for free on development or test machines. And we deliver it both in as a term license for 1 year or any other period, as well as a perpetual license. That's all I wanted to cover for now. So we'll take some questions now, and also wanted to bring our next webinar to your attention while we take questions.